Hello and welcome to the second tutorial video for eIntegrate. Today what we're going to be looking at is the coding of an inbound interface component. If you haven't already watched the previous video about configuring eIntegrate for an inbound interface, then I recommend that you do watch that for a lot of this to start to make sense. What we're going to do is we're going to build on the last tutorial that we did with our example interface here, KT1157. We're going to implement the interface code that's going to process the data that we loaded, the example data that we loaded. In a very basic fashion, we're going to take you through the steps of working with the records to achieve what it is that you need to based on your business requirements. We're not going to look at the actual import of data during this tutorial, more the code that you need to put in place to process your record through and the development guidelines that are recommended. All of this information is provided in the eIntegrate developer guide, so I recommend that you take a look at that document and use that as your developer reference. And we'll start now by taking a look at the interface that we set up and briefly just recovering some ground that we talked about previously. So I'm just going to log back into my eBusiness Suite instance here. Just going to wait for that to load up. I previously mentioned when we were in the previous tutorial about the loading of data via our test.txt file, where we placed a file in the stage directory and allowed the file daemons to load that data into our table, which we can see in Toad here is our starting point. So our value has been loaded in here, our row, a single row. This obviously could be multiple from the file that we load. We've got a record ID assigned of 1. A status of loaded, and we've got a few volume columns here that we've set up. Remember that a lot of these values here in this table, the columns in this table are standard columns for eIntegrate and the standard Oracle Who columns, and the ones that we've got specifically here are these values 1, 2, 3, 4, and 5. Let's just take a look now. I think our eBusiness Suite login has loaded. Okay, so I'm just going to log in here. Okay, so we've got our interface at the top here, KT test, keep test interface 1157. I'm just going to click into the configuration so that we can have a look at what we're going to be working with here. So the main part of the configuration up the top here, the interface definition, is where we specify the name of the interface and some very basic settings. The data file loading method we specified as SQL loader, and we generated a control file which I walked you through in the previous tutorial as to how to load data into your tables. The next section that we're going to look at here is the package definition. So this is our component package that has been generated for us. This is the name of our package here. I'm just going to grab that from the configuration. I'm going to start up Toad. And this is where we go to actually implement our interface code. It's going to launch the describe dialog on that in Toad. And you can see here that we've got a number of procedures in here, and the 4 that we've got here: capture, validate and transform, import, and post-processor. These 4 procedures you will recognize from the configuration that we had previously. So if I just show you that briefly. We've got the capture, validate and transform, import and post-processor. So we're familiar with those from the setup, and the resulting auto-generation that we did resulted in this package being built, and we can see the 4 procedures quite clearly there in the specification. Now there's an additional one here called launch interface. The launch interface is the start point of your interface process, and it's what your concurrent program will call when it starts the process up. You can see here we've got standard concurrent program parameters on that procedure, and we also have some additional input parameters which are ones that eIntegrate uses to launch the process. Now you should recognize these these parameter names from our setup. So if we go through to the next setup screen here, and we click through next again, and we go to parameter definition. You'll see here that the parameters that we have listed in our configuration here have materialized in our package as input parameters for our concurrent program. There's only one of these that you'll actually see on the concurrent program input, and that's the usage ID, which we've discussed previously, so that when we're running the interface, it can be run for a specific source only, so a specific usage of that interface. And if you've got multiple files coming from different locations that process into the same interface, then you can specify which usage you want to use to process the interface. Now, we're only doing a very simple single usage interface here, just to illustrate the functionality. If I actually start up the concurrent manager, if I cancel out of here, but first of all, before doing that, what I want to do is show you in the concurrent manager, I want to show you the concurrent program that launches the launch interface procedure that we've just seen. Now, if we take our interface name, now that name will be the same as our concurrent program name. If we just want to double check that, and it may be that during setup you actually specified a different name from your concurrent program name. So the only sure way of making sure you get the right program name is to scroll down to the bottom of your setup here and look at the concurrent program name that's been generated in here. So we're just going to grab that off the screen now, and we're just going to go to Home. We're going to go into our Application Administrator responsibility just to start up the Forms session. Just waiting for forms to initialize here. Now, once we're in, we're just going to switch our responsibility context back to the responsibility we have set up on this instance for eIntegrate, which is iFramework Developer. When auto generation runs and it creates your concurrent program, it will put the concurrent program into a default request group. The default request group that eIntegrate assigns the programs to is configurable in the profile option, and that can be changed at any time. However, it's more likely that once you've generated your program, you're going to want to assign it to a specific request group so that you can control access to your programs. Now, remember that whilst we're controlling that access via responsibilities on your eIntegrate setup, we also assigned a security function. So regardless of whether or not the person has access to the program, they will only be able to run it successfully if they have that security function assigned to their menus. Again, eIntegrate will check that as soon as you run the interface process. Okay, so we're just going to, if we just close the concurrent manager down, and we just switch our responsibility to make sure that we're within the correct request group. Just going to select our framework developer, and we're going to go view requests. Okay, we're going to submit a new request, and I'm just going to copy in the program name that I took from my eIntegrate configuration here, and we should find that we have a concurrent program that launches, and that we do. Now, it's going to ask us for the interface usage. We can click in here for the value set. There's only one available for this one because there's only one usage, and we can see there it's the default usage that's been selected. I'm going to click on OK. We're going to submit that program. So it's important to understand here that we've not actually implemented any code at this point. So all we've done is set up the interface in the eIntegrate. We've run automatic generation, and we've been able to load data into our table, and we have a concurrent program that we can run and execute and should complete normally, allowing us to view the standard interface output report, which you can see here. Now, there's a lot of information on here, just in the top section about the general information about your interface, what time it was launched, what kind of interface it is, the name of it, the final status of the interface, which is here is successful because we've not done anything. And on the left-hand side, we've got what we refer to as execution parameters. Now, execution parameters are variables that are held in what we refer to as the execution store, which is effectively a real-time table that holds values for these parameters for your interface session, a little bit in the same way that workflow holds attribute values when it executes for a process. eIntegrate works in a very similar way, allowing you to store the history of your execution process, as you can see exactly how it was run. In a lot of these default parameters, we will have the configuration that was set up against the interface at the point in time it was run. It grabs that configuration when the interface process starts, and it will save it in the execution store, and it will use those configuration settings throughout the execution lifecycle. The reason that we hold these execution parameters real time as the interface is executing is so that you can actually manipulate those values during execution. So there are a number of execution store APIs that can be used to set and get these values whilst your interface is processing, that will enable you to influence the way that the interface executes. So, for example, you may decide if you reach a certain error condition that you don't want your interface to be restartable if it ends in error, you want it to terminate. And there's actually a parameter that you can set within the execution store during runtime to set your restartable parameter to terminate. And that will influence the way that the interface is executed. Now, it's configurable as to whether or not these show up on this report, as well as the dynamic parameters, which are down here. Dynamic parameters are ones that are declared by yourself. The additional ones that you put onto your concurrent program, it might be you want to put a file name parameter in there so that you can only process one file, and you can display them on this report. Any interface messages that you put out, errors, warnings, informational messages, completion messages, will show up in this part of the screen, both in summary and in detail, to give you a high-level indication as to how many messages you have in your interface session, and also the detail messages, which will show you which record that particular error relates to. Now, obviously, we haven't run anything here. We've got no information coming out, and so it's not populated. If it was, then this screen would be condensed, and you'd have much more room for those messages to be displayed. eIntegrate uses a workflow to execute your procedures. So the component package that we're looking at has 4 procedures in: capture, validate and transform, import and post-processor. The workflow process will actually execute each of these in turn after it's started. So the first thing that Launch Interface will do is it will accept your parameters, it will initiate your session, and then it will launch the eIntegrate workflow, which will then in turn execute each of your configured interface procedures. The workflow itself is standard. It doesn't need to be modified as part of your development activities, nor does any of the standard XXEI packages, tables, views, and all of the components that are part of it, including the Unix shell scripts. They're all standard and never need to be modified for a particular interface. All of the coding that you will do needs to be done inside your component package that we created during the auto generation. We can monitor the workflow and take a look at the path that it took by clicking into the link here. It's probably going to ask me, no it's not, it's going to jump straight in, that's great. And it's going to show us the path that our integration took. So we can see here that the workflow started. It initiated your session for you, which sets some global variables on the database. It then checked to see if the interface was enabled, and it found out that it was. So it initiated the interface attributes, which is the population of the execution store of your configuration, so that it knows what to work off. It then determined that it was an inbound interface, and so it went into the inbound interface process, came out of that with an active status, and it then executed the interface post-processor, which is different to the post-processor that is on your procedure here. That's used, as mentioned previously, for doing anything you like after your interface is finished. The post-processor in the workflow does a number of cleanup activities and does things like activate purging. It finally then moved into the administration post-processor, which is internal eIntegrate processes. So if you just click quickly into the inbound interface process, we can see in here what that actually does. We can see that what it will do is it will validate the inbound register, which is your configuration, make sure that that's all as expected. It's determined that we need to run the capture process, which is our first procedure in our specification. So it's going to execute capture first. Now the capture procedure will identify the records that we want to work with. It will set their status and it will set the execution key against those records, which we will have to code, and we'll show you that shortly. It comes out of the capture procedure. Just jumped down a little bit too quick there. And it will determine the interface status. It determines the interface is still active, it's not gone into error or warning, and it will then move over and it will attempt to execute the next process, which is the validate and transformation process. And again, it will now execute the next procedure in line, which is the validate and transform procedure that we've got in our specification there. Once that is complete, it will again check to see the status of the interface. It will see that it's active, and it will go into the import process, and the import process will then execute the import procedure that you've got here. It will come out of that, and again, just double check the status. It will see that it is in an active status. And it will then finally launch your post-import process, which will launch anything that you may need to process after your interface is completed. And again, if you want more details on each of those procedures, we're going to go through them in a bit more detail now, but I recommend that you read the previous tutorial to understand the configuration and setup and what each of those are for. And once the post-import process is complete, it will end the inbound execution process. Okay, so we can see our workflow completed successfully. The workflow is xxei admin. The name of the test interface is there for the username, and the workflow key is the ID of your interface plus the execution session key, 656. And we would be able to see that against our, if we just close that window down and go back to our output report, we can see here that our execution key is 656. And think of that as nothing more than a session key that identifies your interface run, your interface job uniquely, and is used to find out what went on during that interface session. The records that you process will be marked against it and can be used to call a various number of APIs. Okay, so we are just going to close that down. Okay, so we've seen how we can run our interface now from the concurrent manager, and that activates our launch interface procedure here. That then interacts with the workflow and starts the workflow, which then in turn calls each of our procedures. It's important to understand that you never need to code anything else than these procedures in your eIntegrate package that was generated when we run auto generation. This is where you should need to put all of your code and shouldn't need to modify anything else. So we're just going to launch into the body here now, and we can see that we've got a lot more things in here in terms of procedures. A lot of these are helper procedures to enable you to do various things during the execution of your code. There's a couple of a few different APIs here to help you to record errors and handle exceptions. Generic ones for checking lookup codes and flex values. Another one for getting messages from the application object library that may have been configured in the eIntegrate. There's an initialize one, which initializes the session that's called internally. You don't really need to modify that. And some standard logging APIs for begin and end of your procedures. So we'll just take a little bit of a more detailed look at this now. We're going to load this into the editor. Just going to load the body. Okay. Now you can obviously modify your header here to conform to whatever it is you need to put in there, the interface name, your author name, and modify these variables accordingly. You can leave majority of this in place. To be honest, it's not specifically needed. You can tweak it if you need to, but there are just some additional ones that help you, additional parameters to help you through the process. Here are some execution core parameter constant that I was referring to. So each parameter in the execution core has a name, and then in the execution core against your interface session, it will hold a value. And you can call them up at any time using a API to recover them and passing in the relevant parameter name to get those parameters. And you can also use a set API that will enable you to set them, and we'll look at that in a little bit more detail shortly. Okay, so if we take a look at some of the helper APIs, begin and record message, just very simply log a call utility package record message API, which will log some debug information in FMD log messages. The same for end record message. The initialize procedure, when called, will set you some global parameter values, which is the execution key, interface ID, the current phase of your interface process. And you'll see here these are the APIs that I was talking about. So we can call this API here using the execution core package to get the current execution key, which at any point will return back to us the execution key that we previously looked at in our interface output report. So I'll just load that back up again. And whilst our interface code is executing, we may want to find out what this execution key is. We almost certainly will need that in each of the different procedures. So it allows us to obtain that value by calling that API. The interface ID will be recovered because this is a parameter that's stored in the execution core. So we call the getExecutionValue API. We pass it the interface ID as the parameter name, and the execution key, which is the global variable that we just populated, and that will return back to us the current interface ID that is running, which is our interface ID, and that's a unique ID that's captured against the configuration. You'll be able to see that in the interface setup. The phase, there's a number of phases that the interface process will go through from the beginning to end of the process. This helps you to track exactly where the phase is. We can see in our output report that the final phase was the control post processor. Obviously you've got the validation capture phase, the validation phase, the import phase, the post processor phase, and you can use that to keep track of where you are in your process if you need to. So what that does is just populate some global variables so that we can use those in our procedures. It's just a convenience method really, just to initialize that. You don't need to call this. You'll see that this code is already called from your capture procedures when we run auto generation, and we'll take a look at that shortly. Just very briefly look at getMessage. We've got a standard API with code that you will be familiar with if you've worked with Oracle eBusiness Suite before, clearing the FMD message stack, setting the name of your message, checking to see if there's any token values that need to be set there. That you can set those up in some global variables before you call this API, and then it will return the FMD message back to your variable. Just some helper procedures there, just to cut down on the amount of coding you need to do. Flex value sets exists procedure that will take in the flex value, the value set name. It will just do a quick check to make sure that flex value exists, and it will return a true or false, depending on whether it exists or not. Very similar for the lookup code exists procedure, passing the meaning, the lookup meaning, type, and code, and it will check to see if that exists for you. A few methods here to help you do various things. So recording an error, this is standard code, and the internal setup of this can be modified to suit you however you want. This is just very basic in that it will accept a record ID to record an error in the event that we get an unhandled exception. So in our when others procedures, this will log the SQL error message. It uses a quite advanced API called process exception, which will actually do a backlog of the error messages off the stack. So it won't just record one error message that you get from SQL SQLerm. It will actually go back up the stack and log all of the exceptions to give you all of the line numbers that fell over during the execution process, which is extremely useful when you're debugging your interface processes. So if you do have a when others clause, and you'll see it shortly in our example procedures, then that will be called to log your error messages. The exception handler is used to record specific exceptions during your interface process. So, for example, not when others ones, user handled processes. This does some very specific things in that it will accept the name of the procedure that experienced the error, and there's a standard variable for that in each of the procedures that you can pass in. It's already there for you. The exception type, so is it an error, is it a warning, what kind of an exception is that? The message that you want to pass in, and whether or not you want the interface to be restartable after this exception occurs. And it will then internally handle the mechanics of setting that up for you. It will set an execution value here that we can see for continue processing. So if you call this API, then what it will do is it will say, I've had an exception and I don't want to continue processing after my current procedure has completed. So if you received errors during capture and you called this particular exception handler API, it would stop the processing from going any further. It may be that you don't want to do that, so you may want to actually remove this particular procedure here, this procedure call. And that's absolutely fine. Like I say, these can be modified. They only affect your interface, and they can be modified accordingly. I would advise that you consult the developer guide to understand the different kind of execution calls and how the const.proc parameter works. If the user said that they wanted it to be not restartable, then it will set another execution value in the execution stall of restart to no, which will prevent the interface from starting up again in the event that it falls over an error, and it will terminate the process. The error handler API again takes a unit name, which is the procedure that fell over, and a restart yes or no. This one also sets the const.proc parameter, which is something that our other one didn't do, and it will set the same const.proc to no. And it will also call the utility package to record a unhandled exception. Like I say, the use of these procedures are completely up to the developer. You don't have to use them, but this is just a way of getting hold of various unhandled errors so that you can log errors. You can, of course, for normal standard errors where you want to just pass it, I've experienced a validation error, I want to give it an error message, then there are APIs available to you which we'll cover in the next 30 minutes or so of this tutorial. I'm just going to close those up now. I'm going to take a look at our launch interface procedure. Now I've actually got some, the standard code that gets generated here I'm going to show you, but I've also got a standard template for you to take a look at for inbound templates, inbound interfaces that should help you visualize some of this. So the first thing we do is we just set the return code up as 0. We obtain the current execution key, and we do that by calling the exit utility package get next execution key. At this point, we haven't initialized anything, so we don't have those variables available to us that we mentioned previously at the initialize messages called. We're doing it manually in this procedure, just as an alternative way of doing it. The interface ID, we're referring there to our GCO interface reference variable, which is populated in the specification, and you'll see that if you look at the specification. But it basically just gives us the interface ID. We're checking to see if the execution key of this session is null. So has the user given us the unique key that we need to use for our session, which is this input here, or do we need to generate one? And if we need to generate one, we'll just call the sequence number and call the next one. It may be that this interface has been launched by another interface which has already generated its key for it, in which case we can just pass it in on our concurrent program call, and it will already have one. But we won't be going into detail as to the scenarios that you would do it for this particular tutorial. We're just going to assume that's null, and it will generate the next execution key. The launch interface process will then set some basic execution values in the interface store. It will populate the execution key. That's the key variable that we need in the execution core to identify our session. And then it will call the workflow, and the workflow will populate the rest of the parameters in the execution core based on the execution key. So it will grab your configuration and it will use that execution key to log the rest of your configuration into the execution store, ready for it to run your interface code. This is code that you shouldn't change. You should leave all of this in place in your launch interface procedure. Now we can start adding additional code in here in the event that we've received in additional parameters into our procedure. And if I just jump back into the interface configuration, we discussed in the previous tutorial about setting up parameters on your concurrent program for your interface, and you can use those in the launch interface procedure to set those parameter values in the execution store. So if we have a look at the setup of our interface, in the parameter definition, we will see that we've got these three parameters. Now we can add new parameters in here, which will set up a new one here. It will set up a new parameter on your launch interface procedure and pass it in. But at this point, it's not been communicated to the execution store. So later on down here, we can add, using this commented code here, to set an execution value using the execution key, the interface ID that we obtained previously, and the various other features to set the parameter name, and we can call the parameter name there. I'm just going and set the value of it, sorry, more importantly from your input, and that will store your parameter input then in the execution store for you to use throughout the rest of processing. Now I'm just going to show you some example code that we've got here, which is on the TeamForge website for eIntegrate, and these files should have been available, as well as the developer guide and various other documents here, which should have been made available to you as part of your project. We're just going to download the example inbound interface code there. I'm just going to log back in. So we're just going to download that. Open that up in text edit. I'm just going to find the relevant part of code for launch interface in the example code, and again you can use this as a guide to help you build up your interface code, and you'll see in here that we have got an example call here to set execution value, which is a bit better than the code that gets generated in the package. So I'm just going to knock in there, paste that code in, and you'll see what we call setExeVal in the execution package. We pass it the execution key, which is in our LV execution key variable, the interface ID, which we generated up here using the global variable. The int usage ID, again, is an input, which is the standard input that you'll get on all of the concurrent programs that get generated for your interface. The name of our variable and the value. Now the pbatch name variable is an example of one that would have been added on to this list had we have specified a pbatch name on our interface setup. So sorry, not that screen. On this screen, we may have put a pbatch name in there, which is an example of where that template comes from. We could have put any parameter name that we want in there, and it would have generated it onto our package inputs, and we could have then used that to store our input parameter in the execution store using that call. That would then be available to us later using another call, another API to retrieve it, called getExeVal. I'll just see if I can get hold of that. And we can see that one here was used in the example code to communicate this p-batch name parameter. And oh, sorry, I haven't copied that properly. Just get rid of that. Okay, and we can see here the same package, execution package, but it's get rather than set. P parameter name is p-batch name, and that would return back to us. We'd want to put this into a particular variable, so we'd want to put declare that as a varchar2, and then retrieve that value into there as a function that returns the actual value. And that's how we swap and use values throughout the parameter inputs and execution store values throughout our interface code. I'm just going to delete that now because it's not actually applicable for this example. So that's the launch interface procedure. Basically, it will just initiate the session, and it will call the workflow, which will then in turn execute your other procedures. Now, the other procedures, which we're going to start with capture, are the key ones that you need to consider. And if you've got no additional input parameters to your interface, you don't need to worry about launch interface. You just need to code it into here. Now, I've got some very basics going on here. The LV unit name is the name of your capture procedure, so that can be used for logging information as to where you fell over. The initialize call will call the initialize procedure to give you access to global variables, and some logging here in terms of beginning and ending your code. Now, I'm just going to use the example package here in our capture procedure. So the first thing that we're going to want to do is we're probably going to want to put together a cursor that selects data from our table. Now, if we remember correctly, our staging table name was available to us earlier on. We could do a query on all objects to get a list of our objects back from the database, and we can see here that our table name, if we just scroll down a little bit, tables is KT1157 stage. We're just going to copy that back to our package. I'm going to modify my cursor. I'm just going to get my indentation right here. And we can paste that in. We'll leave the aliases the same just for convenience whilst we're doing this tutorial. Obviously, you should probably tidy those up. And we're going to set it up in a for update cursor. We're going to say whether status is equal to our input parameter of pStatus, and we're just going to remove this. This was some code that was put in there for the use of the batch name, which we're no longer using. So a very basic cursor just to select some data back in the certain status for update of the execution key field and the status field, which, as you remember, will be are standard fields that get generated in all eIntegrate staging areas. So if you're quick, you'll have noticed that I've popped that in the wrong place there. Copy and paste functionality is starting to wear thin. Okay, so I'm just going to put that cursor back up in there. And then we're going to take a look at the body. So obviously the template's got the same code of initialize and begin record message, and there's some additional annotations in here for you to read through and take a look at to understand the different calls. There's an example of using the get execution value for obtaining the phase, an example of writing out to a file, to the concurrent log file, which comes with our interface process. That's obviously different to the output report. You can write the log as well as you would do anything else. And there's some additional annotations here for you to take a look through. We're just going to take a look at this for loop. This is the main part that we're interested in doing, just to show you how to work with your records. So we're going to pop that code into here. Okay, so we're saying for RC int data in C int data. We're going to process this cursor through. We want to any records that are in a loaded status, and that's a global constant being used from the utility package. We're going to take this LV batch name out because that's not relevant for us. We only need to pass in the status, and we'll also just take that off our cursor. So we're going to process this cursor through in this for loop. I'm just going to remove the comments here, but please take the time to have a good read through that example coding package. And what we're going to do here, the first thing that we do in Capture, the very basic process that we need to complete is to update the status of the row. And we're going to set that to new. We also need to set the execution key, which is the GV execution key. Now, the GV execution key variable is your current session key, and you can always use that global variable. That was populated when we called initialize, so you never need to worry about initializing that global. Okay, and we're doing a where current update, and we're ending the loop, and that's all that we have to do. So if we compile that package up now, then what we should find is that we've got a package body created. So that's our capture procedure. Simply identify the records that we're going to work with and set the status. Obviously, it may be that you want to add some more logic in here. Maybe you want to execute some very early validation logic, but majority of validation and enrichment of data I would recommend that you do in the next procedure, which is validate and transform. So I'm just going to take a look now. What we can do, just to make sure and verify that this has actually worked, we could run the interface, but what will happen is it will actually end in a status of error because it will see that it's got records in a new status, and that's where they'll be left. It will tell you that you need to you've got unprocessed records because we've set them to new. We've said they're ready to be processed, but we've done nothing with them. So we're going to do the validate and transform and procedure first, just to give it some completeness before we do that. So we're going to take a cursor again, and I think what we'll do is we'll actually just copy the cursor that we had in our capture procedure. But we're going to make some fundamental changes to this at the moment. So we're no longer going to need to select just on the status. What we want to do is want to add some additional criteria in here. So we're telling it that we want to match the status of our record, but we also want to match the execution key. Now, this is important because what this now means is that we are restricting the rows that we're going to process based on the execution key that we set in the capture procedure. And that's important because it means it gives us integrity in our interface. It means that we don't process records we're not supposed to, and we're just going to stick the same data throughout the process. Remember that workflow is calling these. They're not called by each other. They don't have parameters on them, and we want to make sure that we're working with the same data set. So that's what we're going to do in here. Now, it may be that if you want to update any data as part of your validation transformation stage, which you probably will do, then you'll need to extend your update of clause to include the fields that you want to be able to update. Please take the time to have a good look at the developer guide in this area. There are some guidelines around how to enrich and transform data. It's important that you don't enrich data or update columns that were originally captured from your file. That's because eIntegrate enables you to reprocess data, and if you update original fields, then you are then polluting the data that you originally received, and it won't be able to reprocess it without corrupting the interface process. So please take the time to read that information in the developer guide. It's very important to the development process and is a fundamental development guideline that must be adhered to when you're using eIntegrate. So we're just going to get back into our example code here. We're going to set up another loop. I'm just going to take quite a bit of code here from the example file. We're going to make some changes to it to make sure that it's going to work with our table. This was obviously built for a different example package with a different name. Luckily the cursor is the same, so we're just going to leave that as it is. But we're going to pass in a status and an execution key. Now, we know that the status of this particular data at the point it got captured was in a new status, and so therefore we're going to restrict the records to only identify records in validate and transform that are in a new status. Please try to use the standard constants that are available in the utility package. That's very important. So we're going to pass in here two parameters, our execution key, which comes last, and our status, which comes first. There's some examples here in the interface code of logging errors and obtaining error counts. It's very important that you read this to understand how to use the utility package record error API. This will log Oracle application messages to the error log for your interface session. You must use apps messages and call them when you log your errors, so that the internal mechanism within eIntegrate will be able to identify the summary counts of the messages that have been used. So please take the time to read this example package through and understand how to call these. But basically, as we're looping through our records, if we encounter errors in our validation, we will want to call these APIs to log those errors. I'm just going to take out those comments there just so that we can see the wood for the trees slightly. So there's another API here called LV error count. So error count on the utility package can be called to identify how many errors we have logged during our interface cycle against our records. We can pass in the execution key. We can pass in the record ID from our cursor. And that will return to us how many errors have been logged against that record. And then what I'm doing here is I'm conditionally then setting the record status in our validation procedure. So I'm just going to take our table name again here. Just update that update statement. So if we discover no errors have been returned, so our error count is 0 for that record ID, then I'm going to set the record to a status of ready, where current of the current cursor record, and if not, if it did receive errors, I'm going to set it to record error. You may also want to then obtain the status of your interface. So once we've finished the loop, and we've finished looping through our records, we've finished validating them, we've finished enhancing them and updating the columns to include new values and things like that, then we may want to examine the status of our interface so that we can determine whether or not we want to continue to process with the import procedure. So in this instance, what we're doing is we are calling the getExecutionValue API to recover the current status of the interface. Remember, the execution store is constantly being updated with the status of your process, your workflow process as it executes. And we're saying, give us the execution value of status. We're then testing that value to say, if the interface is in a status of error, then call the setExecutionValue API for the parameter contProc, which stands for continue processing, and set it to no. Now in that instance, the workflow will check the status of your interface after validation completes, and if contProc is set to no, it will terminate the process and it won't proceed with your import procedure. Now if for any reason your interface was not in error, and you still wanted to skip your import procedure, then you could call the skip imp proc parameter and set that to yes. The continued processing parameter is only observed in the event the interface is in an error status. So in the event that it's not in error, but you still want to skip import for whatever reason, you can do that as well. And this is really just an example of how you can influence the process of the workflow of your interface process by using these APIs. And then we're going to end our process. I'm just going to compile that up and make sure that we haven't got any errors. Okay, we've got a couple of errors there. I've probably missed something because I've been going through this process. Okay, looks like I haven't declared my variables from the process here, so we're just going to grab those out of the specification. Pop those into our specification here. And that's compiled. Okay, so finally looking at our import procedure, there's again, take a look at this code in here. There's various bits and pieces again, but we're just going to grab some code. We're going to delete some of these comments out. Let's put our interface code in under the comments. Going to grab our table name again so that we can update the correct table and select data from the correct table. We can also grab our cursor again here shortly. Again, there's some more references here, just going over the use of the recording error APIs. Please take a look at those to understand how you can manage and work with errors in your interface process. We're doing the same thing again here in terms of checking the error count. We're passing in the execution key and the record ID from our cursor to find out how many records are going to error, and then we're going to just replace these in with our table name, and we're going to set them to complete or error dependent on how many errors were assigned. There's also an additional API here called record completion message. A completion message can be recorded once per interface session. If you call it more than once, it will overwrite the previous. But it's a standard message that you can set up. You can call this message whatever you like in Oracle, and it will record that completion message in the interface output report. It may be some information about how many records are processed, or even just a confirmation message to say that the interface is complete. And it's more of a usability thing so that the users can be communicated with in the same way that they are when you call the error logging APIs. Those errors will appear to the user on the front end. Okay, so we're just going to grab our cursor here, which we missed slightly. And in fact, I think what we'll do is we'll just take the cursor from our previous validation procedure. We'll just take those variables with us as well, just in case I think we may have used those. Okay, we're going to take the same inputs to that again. Just going to copy the call for the status. Remember, at the end actually of our validation procedure, we set the records to a status of ready. So that will be the starting status for our import procedure. So we need to capture that global constant. So we've already swapped out, we've got our name here for the correct table. We've got our cursor. We're just going to pop in there the status of ready. So when we come into import, we want to select records in a ready status for this execution key, and then we'll do our processing. And this is where you would call somewhere in here before you start doing your updates and your error counts. This is where you'd actually put your import code, which may be your API, or it may be your open interface, and you put that code to whatever requirements you have into that loop. Okay, so let's just try and compile that and see if we can successfully compile. Okay, it's completed. You can see at the end there where we did our error count checking, we're going to update the record to a record status of complete once we are finished. So our status has gone through loaded when it was initially loaded from file. When capture ran, it updated it to a new status. When validation ran, it updated it to ready, and when import ran, it updated it to a complete status. Now our package is compiled. We've got our basic code to loop through our records. Obviously you would have additional code in here for your validation, for your import code, implementing whatever features it is that you want to import. You'd be calling the log error APIs to log your errors, and various other things that I'm sure that you would be doing as part of an inbound interface can be implemented in these 4 procedures. Of course, there is always the post processor that can be called, and the post processor, you can put whatever you like in here in terms of launching additional processes. They may be standard Oracle processes, you might be launching workflows, you may even want to launch another eIntegrate interface, which there is an API for available in the developer guide. but that post processor is guaranteed to have had a commit by this point, and you can use it however you see fit. So there we go, our interface has been put together. We've got code in there. We're going to run a request in. We're actually just going to do a copy of that process. And we're going to submit that interface. And now that we've got some code in there, then we should start to see some additional information perhaps coming up on the output report. We haven't set up any error messages here. We haven't logged anything additional to the standard code from our template, so there won't be very much in here, but you can see it's completed, and we will be able to demonstrate that at the top here we can see that the interface status was successful, which was what we were expecting. We've got our execution key, which we've been using in our code to call various APIs, and at the final phase was the control post-processors. Now, that's what we would expect it to be if it's finished its execution successfully. But down here now we can see some additional messages that we couldn't see before. So this is the completion message that I logged that you saw. Now, it hasn't actually found that XXEI completion message in the application object library, so it's just logged the message name, but that could have been whatever we wanted it to be. And you can see there's a tick against that to say that he completed successfully. We've then got a number of other messages here that have been logged by the eIntegrate software to give us some tracking of what happened during the process. And we can see here at the end of the inbound capture process, we had one record in a status of new. At the end of the inbound VT stage, we had one record in a ready status. At the end of import, we had one record in a complete status, and after post-import, which is our post-processor procedure, we had one record in a complete status, which is what we'd expect to see as we go through the life cycle of a record through the interface. Okay, well, thank you very much for watching this video. Hopefully you can see the power of eIntegrate in terms of being able to quickly put together interface component code in a very short time frame. I think less than 40 minutes we've been able to put that interface together. Please, if not, then take the time to review the previous tutorial to this, and also take a look at the eIntegrate developer guide, and after watching these tutorials, that developer guide should start to make more sense and helping you as a reference as you go through your eIntegrate developments. Thank you very much for joining me, and happy coding.